Dark matter as a concept has been around for a long time,
Yeah.
more than 85 years.
Right.
And the general status has evolved a lot since then. So we have a much better understanding of what dark matter is not
Okay.
and what it could be.
Right.
So originally, the concept of dark matter is just that when you look out at the universe, you can try and measure the mass of objects,
Right.
Galaxies or clusters of galaxies at the largest scale. And you can look either at how much light they produce and try and measure the mass by essentially counting the number of stars or
Right.
counting the number of galaxies in a galaxy cluster. Or by measuring how fast things are moving, because the gravitational attraction pulls harder, and the harder it pulls, the faster things go.
Right.
So you would hope that those two methods would lead to the same mass for an object,
Right.
but they don't. They're discrepant.
They're significantly so?
Significantly so, yeah.
Yeah.
So it's roughly a factor of 6 that
I
they're
see.
off by. So
Okay.
there's about 6 times more matter than what we can account for with
Yeah.
what we see.
Right, that's a lot.
That's a lot, yeah. And so originally this observation was made, far back early in the 1900s.
Right.
But there were still a lot of things that dark matter could be. For example, rocks, asteroids, rocky planets. They don't emit much light,
I see.
right?
Okay.
And so they are dark,
Yeah.
and they are matter.
Right.
So could they be the dark matter?
Oh, I
Right.
see.
Right.
Interesting, yeah.
And so this
But
is
so much of that?
right. So much of that, yeah. So this was a question that was around, right?
Right.
Could there be normal matter
That's cannot be
that's
seen.
dark? Yeah, right. And over time, we've gradually, through various techniques, narrowed down the fact that it can't really be normal matter that makes up all of the dark matter.
Yeah.
There's some component that is in rocks or rocky planets or gas.
Right.
Gas was a big one, actually, that it's hot and X-ray emitting, but you
Right.
don't see optical light.
Exactly.
And so it was, that was a big one that people were like, oh, maybe
that's
this
the
is
one.
it.
Right.
But as our instruments get better and better, we find that there's really some component of matter that's not made up of the things we're used to
Right.
experiencing,
Right.
and is actually outside of what we call the standard model
Right.
of particle physics that makes up this extra mass.
Yeah.
And so all of that has come since the discovery. So there's been enormous improvements towards that. And in the last several decades, the search for this new particle that could be making up the dark matter has really scaled up.
I see.
And so that is through sort of 3 different experimental techniques.
Yeah. Well, you say particle or particles?
Yeah, well, that's an open question.
Oh, I see. It could be
Yeah.
a single particle.
It could be
too.
a single one. It could
Oh,
be.
I see.
It could be. More complicated. So if you look at
Yeah.
things that we experience around us,
Right.
right?
Right.
The vast majority of the matter that we experience, is made up of protons and neutrons, right? And so maybe dark matter is similarly composed of one
Oh, I see.
major component,
Yeah.
right? And then other minor components. Maybe it is just one component.
We don't know that. Right?
Yeah, maybe it's
Right.
a synthesis of many.
I see.
right?
Okay.
It's more a sense of excitement and opportunity, right? I mean, I think, trying it's a huge opportunity
Right.
we have to make very large steps towards increasing our understanding of the fundamental building blocks of the
Right.
universe.
Right. Right.
And I'm not I don't sit troubled in my
I'm sure
chair,
you don't.
worried that
That's
we
why
don't
you are
know
in
anything.
physics, right?
Right, but it is very exciting to try and actively seek out, what the dominant components of the universe
Right,
are.
right.
That's a great question. So, so there's the dark matter problem,
Yeah.
which I described,
Right.
which is sort of an astrophysical problem. We see the signatures of this missing mass when we
Right.
look out at the universe. There's another problem in particle physics, which is essentially why do the particles have the masses that they do?
Right.
And why is that scale so much different from some of the fundamental scales at which we believe, particle physics operates?
Right.
And this has led to another, this is another big question. This is a big question in particle physics now, where one of the possible solutions is that you have an entire spectrum of new particles that haven't been discovered yet.
Right.
And so this is often called supersymmetry. Supersymmetry is one theory of that.
Right.
And the idea, one thing that's been very exciting is that perhaps these two problems that at first seem disconnected could both be solved by the same extra particle.
Oh, I
So
see.
that the
Okay.
dark matter particle could also solve be a
Oh,
supersymmetric
see.
particle. And so the Higgs was something that we very much believed had to be there,
Right.
right? And it really tied many things together. The dark matter problem is a little more of still searching for a solution to a problem where there are several possible solutions.
Okay.
And so it would be very nice to be able to solve both of those at once.
Right. Right.
But it's not required. I mean, we may find dark matter and it may not be supersymmetry.
I see.
Well, I think it's just that, right?
Okay.
That it's one of the big questions,
Right.
and it's very exciting because there's a lot of opportunity. There are a lot of things we don't know,
Yeah.
and it's a big problem, and there are a lot of people working on it, and there's a lot of opportunity to sort of chink away
Right.
little by little, sort of carve out your own corner where you start understanding things very well, and that adds to the
Exactly.
overall picture.
Knowledge. Yeah.
A lot of the dwarf galaxies that we've been finding are, let me see if I can do the conversion. So, yeah, they're at maybe 100,000 light years
even
or
closer.
so. Some are closer, some are farther.
Okay.
Some are at maybe, the most distant one we found is probably at about 1 million light years.
Oh, I
So
see.
it's over a range of different distances.
That's a big range.
Yeah, but these are things that that are very much in our local neighborhood
Off the Milky Way.
of the Milky Way. Yeah. Dr. Chakrabarty's work, right? So here's us,
Mhm.
right? We sort of sit. I actually have a galaxy.
Okay.
All right. So let's say this is the middle of the galaxy, right?
Okay.
And it stretches out like this,
Right.
And this is us. I believe that Galaxy X was sort of over
Right.
here,
Right.
So you look through the Milky Way and you actually see it over here.
Okay.
What we're looking at are dominantly things that come out of the plane of the galaxy.
Oh, I see.
Yeah,
Okay,
and
I
so,
see what you're saying.
Right,
In a
right.
sense, you're looking out. Or looking
yeah,
down.
Right,
whatever.
right, exactly. Yeah, and so the distance that we're measuring is the distance from us to
Oh, I
that
see.
galaxy,
That's
and
interesting.
there's another distance from the galaxy to the center of our
Yeah.
galaxy. It turns out that the plane of the galaxy is not perfectly aligned with the plane of the solar system.
Right. Oh, I see. Okay.
and
so
then-
again, that's another
right.
dimension to it, right?
Right. And then the Earth's orbit is not exactly aligned with the solar system.
Exactly.
So yeah, it's complicated. So we do live within a bath of dark matter.
Exactly. Okay.
That's the idea. So similarly, we live within a bath of neutrinos.
Right.
So neutrinos are much lighter particles, but they're similarly hard to detect.
Right.
And it took a very long time for us to actually discover neutrinos. and then to measure the very rare interactions that do occur as they pass through us all the time. So the idea of dark matter is very similar to that, that there are these particles that interact very, very rarely and pass through us all the time.